Hello everyone, welcome to this class. We'll be talking about LCD display. So you guys will learn how to work with LCD and LCD library. We're displaying several information and text on an LCD screen. So let's jump into the project. All right, so this is our blank project. You just go back to just clicking this menu from your previous project. It will take you to your dashboard, and then you can click on start new circuit so you can start a new project. Okay, so you for us to start, we have to look for our Arduino Uno and then drag out the breadboard. Okay, so now you look for our LCD, that's the liquid crystal display. So you look for it. Hmm. Okay, so if you're working with LCD, you will not see LCD on the basic components. Okay, so these are all basic components. LCD is a little bit pretty advanced and really complicated to work with. So these are just for basic use, but you will not see the LCD on these basic components points here. But we can see potentiometer, which we will be able to use later. So you have to click on um, your basic and then select all, so you can see all the components available here. So you see there are lots of components, lots of sensors, say force sensor, flex sensor, IR sensor. There's so many sensors here. So you see a lot of things here. There's a lot of components you can work with. See a new pixel light, new pixel strip. So mini servo motor. There's so many things. Okay, so here is the LCD 16 by 2. So let's drag that into our screen. So as you can see, it's a little bit big. We're going to be scared of the size. We will do what we need to do with it. Okay, so we will have to display some text on the LCD. So the LCD has a really complicated way it is being wired. Okay, so you need to look at the pin configurations very well so you understand how to wire them. Alright, so there are 16 pins here from GND to LCD cathode. So the GND, you just connect it to the ground. So what we'll be doing here is that, first of all, on our breadboard, we will click inside an empty hole on the minus wheel, drag out the wire, and connect that wire to GND on the Arduino board. Good. So to give us one centralized GND. Alright, so let me change the color of my wire to black. Okay, now for the plus wheel, click inside, drag a wire, and connect that part to 5V for 5 volts power. Let's change the color of my wire to red because that's for strictly for power. Okay, so the first piece for my LCD is GND. So I click inside that hole. There's a cycle in there. It's a hole where you can plug in your wire. So click inside that hole and put it on the minus wheel because that's also for GND. Want to use one centralized GND. So beside the GND is the 5 volts, which is power. This is called VCC. So click inside, drag a wire, and connect it to the plus side of the breadboard. So VCC is for power, and that's why we're using the red. So for us to use this VO for constructs, we have to use a potentiometer. So let's go over to our components page and look for a potentiometer. So here is a potentiometer. So potentiometer helps us reduce and increase the current of the that's entering into the LCD, so you can increase and decrease the construct. So the first side of the resistor is the terminal 1. The first side of resistor is the terminal 1. So this, just on this column, you click on an empty space connected to terminal 1 of the potentiometer, drag out your wire and connect that to the plus rail on the breadboard. So that is for power, to power up the potentiometer. So we use red. So then the middle part, which is the wiper, you click on any of the empty hole inside the middle part of it, then connect that to VO uh, on your LCD screen. VO, or the construct. Then you change that color to blue because it has its own different usage. So now lastly, for the terminal 2 of the potentiometer, you click inside an empty hole on the same column. Then you connect that to the minus rail for ground. So connect that to G and D. So the next one for the LCD is called uh, RS. That's register select. So RS for register select. Click inside the RS. So we connect it to pin number 12 on the Arduino board. So connect that to pin number 12. So it's just a register pin for data transfer. So we change the color to yellow. Yeah, because these two are actually different. All right, so next is the read and write. That's the RW, read and write. So that just get connected to ground. So you take that to ground. So don't mind the complexity of the wiring. You just check the schematics when you have any issues, and then you can correct yourself. So we change the color of the wire to black, which signifies ground. So the next pin here is called the enable pin. So we'll connect that to pin 11, digital pin 11 on the Arduino board. So we take that wire to pin 11. So if you can see, our wiring is a little bit more complex now. So that will also be the yellow wire. So the next set of wires we will start connecting are the four set of wires, which okay, so the next set of wires, we just count four spaces: one, two, three, four, and then from the fifth point, which is DB4. DB4, that is digital. I think that's digital pin 4 for the LCD. So you click that DB4, drag out your wire, and then connect it to digital pin 5. So don't worry about the messy wires. You just need to follow from the start, then look at the schematics. You understand. So connect that to digital pin 5 and change that wire to um I'm going to use pink. Then DB5, you will take that wire and connect it to digital pin. So I'm going to connect it to digital pin 4. And I'm going to change the wire to pink again. Third one, same thing. Take my wire, connect it to digital pin 3, then change the color to pink. So the last one, which is DB7, drag a wire from DB7. So these are basically for communication, for you to be able to write to the LCD, and you'll be very sure that what you wrote can be displayed on the LCD screen. So that would be also pink. Then lastly, you see two LED anode and LED cathode. The LCD has an LED inside of it that displays light. So it enables for you to display light so I can see what is written on the LCD correctly. So the LED cathode is definitely the positive part of it. So you have to go take a resistor, drag out a resistor here, then change the resistance to 220 ohms. Good. You place okay, let's rotate it. Good. So place it on the breadboard. So we click inside the LCD anode on the LCD, drag the wire and position the wire in the in an empty hole that's connected on the same column with the first terminal of the resistor. So we change that wire to red. So make sure it's connected on the same terminal with the resistor. It must be on the same column. The other side of the resistor, you click inside an empty hole and then drag out a wire and connect it to the plus rail of your breadboard. Then you convert that wire to red. So what this simply does is that the 5-volt power goes out from this, it takes a 5-volt power from this line, it gets inside the resistor. The resistor compresses the power and then sends the compressed power into the LCD so that the LCD's LED will not explode. So the lights on inside the LCD will not explode. So LED cathode, you click inside, drag a wire and connect it to the minus side of your breadboard. Then you change the wire to black, which signifies um black. That's for ground. All right, now it's time for us to program our project. So we've done the wiring. You have to check your wiring properly, is it connected properly, check all the wirings, your pins. So you need to make sure that everything is connected properly. We're done with the wiring for our project. It's time for us to move into the coding aspect. So click on your code and then open up the text. So click continue. So these are default text. Let's just move everything here and then move everything in here too. So our void loop and void setup will be empty. All right, so now here let's type in let's import the liquid crystal library. So this is liquid crystal. So just click on include, import it automatically for you. So underneath it, we just write an int. Let's make it a constant int. So let's say constant so nobody can change it. So constant int and the value of this int will be, and the variable name for this int is, let's just give it rs equals to 12 because this rs pin here is connected to pin 12 over there. So rs equals to 12 comma, then you say the next pin here, which is enable, say en will now be equal to, so this is like a long line of int variables. So instead of making it one after the other, creating int, we can just put integer on one line and put all our variable names and the values. So it will recognize it as a variable with all integer data type. So en will be connected to pin 11, and then here will be our db4. So comma db4 will be equal to pin number 5. So it's 5, give a space, 5 comma, the next one will be db6. So we say db6 will be equal to pin number 4. So 4, no sorry, db5, so which is on pin number 4, DB6, DB6, which will be pin number 3, and then lastly DB7, which will be on pin number 2. Okay, so we close that with a semicolon. All right, next we'll create an instance of liquid. So this is the main object, liquid crystal. All right, so this is the parent object. So now I want to create a child instance. So we just type lcd, then open up a bracket and close it, and then close the statement to semicolon. We just do here, we just type the digital pins we used. So we type rs, comma, en, comma, db4, comma, db5, db5, comma, db6, comma, and lastly db7. Okay, so we're done with that. So inside this LCD instance, you just have to put all the variables we created up here. You just have to put the variable names here so to know which number we're talking about. Okay, so now in here we just say LCD, then call a method, say LCD dot begin. So it will start a communication protocol. So we'll now put in the particular LCD working with, which is 16 by 2 character LCD. All right, so now let's try and print something. So we say LCD dot print, and open up a bracket and close the brackets, close the semicolon, and put a double quote. Sorry, put a double quote 2 times. So in between the double quote, you type in the message. So I'm going to say welcome. All right, so let me try and see and print my message. So you click on start. Okay, so a bit of syntax error. So I'm just put my S over here. So you have to be really articulative on when you're typing in your code. So click start simulation. Okay, so started. Okay, so we changed the S. We just added S on our liquid crystal to spell it correctly. Then let me type in hello world. So let me change from welcome to hello world. So let me use a more longer text. All right, then click on start simulation. Okay, so if you see now, my display is blank. So I have to increase the construct for my potentiometer. So just moving it clockwise. All right, so if you look at my screen now, you see hello world. So hello world is now displayed on my screen. So let me go back to my code, stop simulation, and then change it. So I'll come inside the loop function, then I call a function saying lcd.clear. So this is a method inside the LCD library that clears everything inside. And then here I can print something new. Say lcd dot print close brackets man, or let me just say electronics. So let's say electronics. Okay, so it doesn't print more than 16 characters. So let me just show you something. So click on that, click on start simulation again. So you see it said hello world, and now see it just keeps dancing around because we didn't add any delay to it. So let's go add a delay. So anytime you're using your void loop, after putting a print, you have to put a delay so that it will be showing for a particular amount of time before it get wipes out. So it will stay for 600 millisecond or 0.6 seconds. So you see, just showed on the screen and it just keep looping around and keeps displaying the same thing. Okay, so that's the end of this class. Now next class we'll be working with uh, ultrasonic sensor. So stay tuned.